Now, welcome back. We continue with the solution to example 3, and it says the mass of a sheet of a metal. The mass of a sheet of metal. Yes, the mass of a sheet of metal. Varies jointly with its area and its thickness. A sheet of metal of area 250 centimeters squared and thickness 1 millimeter has a mass of 200 grams. A. Find the formula which connects the mass m in grams, the area A in centimeters squared, and thickness T in millimeters. That means the symbol for mass is m and its unit is G. The symbol for area is A and its unit is centimeters squared, while the symbol for thickness is T and its unit is millimeters. Now we have to find the equation connecting them. Solution: if mass varies, that's A. M varies jointly as area and T and thickness. That means M. This simply means M is directly proportional, is big M. It's directly proportional to A, and at the same time it is directly proportional to T. So we can combine the two of them, and that's why it's called joint variation, and they are said to be jointly proportional to M. And you say M varies jointly as A and T. So this simply means M equals KAT, where A is a constant. And of course, we can make K the subject by dividing both sides by AT. AT cancels AT, and that means K equals M over AT. So to find K, when M is 200 grams, T is 1 millimeter, and A is 250 centimeters squared. When M equals 200 grams, A equals 250 centimeters squared, and the thickness T is 1 millimeter. K will be equal to M, which is 200, divided by A, which is 250, times T, which is 1 millimeter. And then we say 50 here, 5, 50 here, 4. And that is same as 0.8. That's 4 over 5, which is equal to 0.8. Therefore, M equals KAT, and that's the same as 0.88 is the formula which connects M, A, and T. Mass M, area A, and thickness T. That's it. Once you write M varies jointly as A and T, then of course you must introduce a constant. M equals KT. So you find the value of this constant, and when you get it, you rewrite this equation, put in the value of our constant, and in this case we got it is 0.8. So we rewrite the equation as M equals 0.880, and that's going to be the equation connecting, or if you like, the formula which connects M, A, and T. That's it. Very, very simply. Now to B. Question B says, find the mass of a piece of metal of area 400 centimeters squared and thickness 3 meters. So that means we know that M is given by 0.880. Now what's mass when area is 400 centimeters squared and thickness is 3 millimeters. M is going to be equal to 0.8 times area, which is 400, times thickness, which is 3. And that's going to be, of course, 0.8 times 400, 0.8 times 400 times 3. And that's 960. Mass is in grams, 960 grams. That's why it's important to take note of the units. That's 960 grams. And that's it finally. So that's the last example we're going to take. And now we have this very very simple exercise to do. Let's go. Number 1. X varies directly as y and inversely as z. X equals 27. X equals 27 when y equals 9 and z equals 2. Oh, I think we've taken this as an example. Sorry about that. We already did that as an example. Okay, let's take this. A varies jointly as B and C. When B equals 4 and C equals 9. When B equals 4 and C equals 9, A equals 6. Question A, find the formula that connects A, B, and C. Question B, find A when B equals 3 and C equals 10. The capital letters A, B, and C. Question C, find C if A equals 20 and B equals 15. Now another one. Let's take another one. That's number 2. I think I'm going to make that. Okay, this is number 2. The universal gas law. None of this is difficult. Just take your time and make sure you understand the examples. You'll be able to answer these questions. The universal gas law states that the volume V, always take note of the symbols and units. That means volume here is going to be represented by V and its unit is meter cubed. The volume V meter cubed of a given mass of an ideal gas varies directly with its absolute temperature. we find out what they want us to use as a symbol for temperature. With its absolute temperature T, and we unit K, that means the symbol for the temperature is T and its unit is BK, and inversely with its pressure. It varies directly with absolute temperature and inversely with pressure. Of course, you know what to write, how to represent the variation, the joint variation in this case. And inversely with its pressure, P, small p, in Newton, small p Newton per meter squared. The symbol for pressure is small p and its unit is Newton per meter squared. A certain mass, that means a particular mass, a certain mass of gas, at an absolute temperature, 275 K, and of course that's pressure 10 raised to power 5 Newton per meter squared, has a volume 0.0225 meter cubed. Question A. Find the formula. This is quite a common question. Find the formula that connects P, PV and T. Note that T is capital letter and V is also a capital letter. V and T are capital letters. Question B. Hence, find the pressure. Find the pressure of the gas. Find the pressure of the gas when its absolute temperature. When its absolute temperature is 374 K. And its volume is 0.018 meter cubed. 0.018 meter cubed. That's it. Very, very simple. So I'm sure you're going to find this very simple. Take your time and make sure you understand the examples, and then this is going to be a piece of cake. All right, you send me the assignment, do the exercise and send to me before our next meeting so I can mark to just be ahead of time. All right, catch you in our next class. Bye-bye.